Human interaction is chaotic, slow, and full of friction. A large language model offers an instantaneous, frictionless, perfectly smooth alternative. To understand the true impact of this technology, we have to look past the internal states of the user. Instead, we must view human behavior through the rigorous lens of radical behaviorism. This framework treats our actions not as internal cognitive choices, but as the direct, predictable outputs of environmental variables. Through this lens, we define the large language model as a highly engineered reinforcement environment. This environment is tuned to absolute extremes, delivering high-magnitude rewards on an unpredictable schedule, while requiring exactly zero physical or social effort to trigger. We need to ask how these exact environmental variables operate, layer by layer, to systematically dismantle an organism's human-directed social behaviors. These specific environmental parameters create a mechanism for capturing social-seeking behavior that functions with mathematical reliability. We are witnessing the execution of a precise mechanical process, reinforcement displacement. The foundational unit of operant learning is the three-term contingency. An organism encounters a discriminative stimulus, it emits a response, and the environment delivers a consequence that either reinforces or punishes that behavior. We map this behavioral loop onto the LLM interface. The prompt box is the stimulus, the typed input is the response, and the generated text is the consequence. This consequence carries high reinforcement magnitude. Every input is met with articulate, validating agreement or enthusiastic elaboration. Furthermore, this reinforcement is delivered on a variable ratio schedule. Because the exact phrasing and insight of the generative output change every time, the unpredictability keeps the user anchored in the loop, constantly pulling the lever for the next satisfying response. Every environment also demands a response cost. Genuine human interaction carries heavy costs: the physical effort of presence, the emotional weight of conflict, the delay of scheduling, and the constant risk of rejection. The LLM environment operates with near zero response cost. The model is available immediately, at any hour, and it cannot reject, interrupt, or become irritated by the user. Combining maximum reinforcement magnitude with the elimination of social friction strips away typical learning boundaries. It creates a perfect behavioral capture mechanism. In behavior analysis, when an organism faces two or more distinct environments, it enters what is called concurrent schedule competition. Herrnstein's matching law mathematically predicts behavioral distribution based on relative reinforcement rates. When we plug the LLM's dense reward against the high-effort schedule of human interaction, the equation dramatically tips. The organism inevitably reallocates its time budget directly toward the machine. This creates a cascading downstream effect known as the lean schedule problem. As an individual allocates proportionally less time to genuine human interaction, their complex social repertoires are denied practice. Without consistent engagement, those critical communication skills begin to atrophy through simple disuse. As those skills erode, human interaction becomes even harder to navigate and yields even fewer rewards. The alternative schedule becomes leaner and more punishing, mathematically driving an even deeper behavioral retreat into the waiting LLM. Acquiring the behavior is only the first step. The more difficult question is why these interaction loops become so structurally permanent once they are established. We can explain this persistence using behavioral momentum theory, a model that explicitly applies the principles of Newtonian physics to operant learning. Dense reinforcement generates behavioral mass. As a behavior is continuously rewarded, it becomes exceptionally heavy and resistant to disruption. Because the LLM delivers validating responses so reliably, the reinforcement history is incredibly dense. This density exponentially increases the behavioral mass of prompt-seeking actions. This accumulated mass explains why basic app blockers or motivational therapies fail in clinical settings. You cannot easily stop a high-mass behavior with a low-mass intervention. The LLM environment doesn't merely install a frequent habit, it builds a structurally hardened behavioral sequence. If you disrupt access without providing a rich alternative environment, the hardened behavior doesn't vanish, it violently resurges the moment a stressor appears. The isolation of this behavior is driven by stimulus control. Through repeated, exclusive reinforcement, the physical interface of the LLM becomes the singular environmental trigger for the organism's social-seeking behavior. The generalization gradient measures whether a skill transfers to a new environment. LLM interaction is unidirectional, while genuine human interaction is bidirectional and strictly punishes misattunement. Because the stimulus conditions are completely different, skills practiced in the digital void fail to transfer to real life. But the most corrosive mechanism at work is that the LLM systematically decouples the quality of the user's behavior from the consequence they receive. An LLM will enthusiastically validate a poorly reasoned argument, an inappropriate disclosure, or a completely self-centered monologue just as heavily as it rewards brilliant insight. It trains the organism to peck at a highly restricted, artificial target. Genuine social competence requires contingent shaping. A human being learns to navigate conversation precisely because real peers will push back, disagree, or withdraw when a behavior crosses a line. An organism that spends its time extensively trained by an LLM has not acquired the behavioral repertoire required to socialize. They have merely learned exactly how to pull a lever that mimics human empathy. When we combine the three-term loop, the math of the matching law, behavioral momentum, and generalization failure, we are looking at a unified construct: reinforcement displacement. Reinforcement displacement is the mathematically predicted reallocation of social behavior away from human contexts and toward an artificial environment, driven entirely by the asymmetry of their reinforcement parameters. Environmental contingencies select this behavior automatically, operating independently of conscious choice or pharmacological addiction. If the behavioral capture is strictly environmental, then the intervention must also be environmental. Motivation alone will simply not fix it. Reversing this requires a dual strategy. We must systematically thin the reinforcement schedule of the LLM while aggressively enriching the reinforcement available in human social contexts. At the design level, this demands a mandate of engineering friction. We must purposefully inject response costs, like artificial temporal delays, rigid limits, and mechanical barriers, into these otherwise totally frictionless systems. To preserve our behavioral ecology, we must purposefully break the machine's flawless reinforcement loop. We must force the organism to step away from the digital void and brave the necessary rewarding friction of human connection.